I think we're live. Let's see. Yeah, streaming. I may also take a look at the chat today, but we'll see about that. Let's begin. So where did we leave off? I'm pretty sure that we already have a fully working implementation. First thing we're gonna do is change the token name and symbol, so it's not ZXX anymore. This is now the EMP token. So this is the Enzo Nicolas Perez token. Yeah, very happy about that. We need mint and burn. So mint increases the total supply, burn decreases it. So this is not going to be constant anymore. We want to remove the constant from the total supply. You can start this way. This is fine. And well, how about we do this? We just remove constant, and like we've done previous times, we figure out if this and this, if they cost two S loads, so 2 reads from the state instead of 1. We want it to just be 1. We will debug this, and any one of this should do. We do the setup, and we assert the total supply. Oh, no, this is what we want. The new token, we want to go in there and look at what this should. Okay, let's do it again. I want to go inside the constructor. There. Total supply, that's 100 million. Oh, no, I'm sorry, this is, I'm an idiot. Since this is the constructor, there's no state yet. So this is fine. This is all from it all goes in properly. That is not an issue. Okay. Let's carry on. What do I want to do? I want to add a mint function. Mint. What do we need? We need to mint to an address, and we need to mint an amount. This is external. I have no idea if the standard is to return something, but since it ends up being a transfer of sorts from the 0 address to the 2 address, then let's have the Boolean. And the simplest form would be that the balance of the 2 address is increased by the amount. The total supply is increased as well. And what else? We emit a transfer from the 0 address to an amount. And we return true. We increase. This looks good. Of course, there are no permissions, so anybody can mint tokens. We're gonna fix that. Burn is the exact opposite. So can we just copy everything? We decrease the balance. We decrease the total supply. Well, this will function more like a, let's go one step at a time. What should we do? Should we add permissions? Should we do a test? Yeah, let's add somewhere here. Let's add an address, owner, whatever this is. This could be. The only thing I dislike about this kind of things, every time I have to add functions that increases. I don't like having big contracts. I like contracts to do the least amount possible, but the owner is the message sender. And then here we require that message sender equals the owner, or we say not authorized. And let's mint or not authorized. Increase. That should be it. Let's write a small test. Function test mint public. So we mint to the address, let's say the 0x2 address, we mint 1 ether's worth. And we assert two things. First, that the balance of 0x2 equals 1 ether, and what is this? What did I do? This. And we assert that the total supply equals, where do we have, well, we get the total supply, and then we assert that it is equal to the total supply plus 1 ether. Okay. Run our tests. They all pass. That's good. Let's do a fail. I should really just, there is no need to send them all, but that's fine. Oh, and I should be checking the returns, but it's okay. Return cxx.mint. And we'll do a function test fail unauthorized mint And we'll have the user one try to do a mint to itself for 1 ether, and that should fail. We need to give it the token. Okay, so far so good. It increases. So burn, the simplest one is just to let anybody burn their own tokens. The other one is to let other people burn their tokens with like a, you know, similar to a transfer from. But you know what? Before that, let's go over the ERC20 token standard, because there may be things that we've missed. Like, you know, tiny things. For example, we only emit the approval here, but transfer from actually reduces the allowance. So I'm not sure how other tokens do it, but my instinct tells me that there should be a new approval event here. But let's see what this says. So the token specification, callers must handle false. Callers must not assume that false is never returned. In our case, we never return false because we revert. Name returns name of the token. Symbol, that's okay, that's okay. Decimals, total supply. This is fine. And keep in mind that name, symbol, and decimals are optional. Like, everybody has them now, but the first version of wrapped ether, pretty sure didn't have decimals. Maybe the first version of the MKR token, total supply, balance of, that's okay. Let's see this one. Transfer value amount of tokens to address 2 must fire the transfer event. It should throw. If it doesn't have enough tokens, this is fine. Transfers value from to it must fire transfer event. The transfer from method is used. Withdraw workflow. Yeah, allow a contract to transfer tokens on your behalf. It should throw unless the from account has deliberately authorized the sender. Transfers of 0 value must be treated as normal transfers and fire the transfer event. Okay. Approve spender to withdraw from your account multiple times up to the value amount. If this function is called again, it overwrites. That's okay. To prevent attack vectors. Getting it. Allowance returns the amount. This is okay. The events transfer must trigger when tokens are transferred. This is okay, including 0 value transfers. A token which creates new tokens should trigger, right? There are other tokens that before it was common to have mint and burn events, but you know, transfer from and to the 0 address are it's what everybody's using now. Approval, it must trigger on any successful call to the approve. So that's it. Doesn't say anything about triggering approvals in any other cases. So we're good. Our implementation is, I would say, complete. Oh. Neighbors' dogs are barking. So let's add a simple burn and then try to do something with the the transfer and the transfer from. What would a burn look like? Function burn. Let's just burn first the owner's own tokens, because I don't want to focus on this. I want to focus on debugging. So we will do we will reduce the balance of the message sender, and we will reduce the total supply. We will emit a transfer from the message sender to the 0 address for the amount, and we will return true, and we will call it a day. That's fine. And we will just do one test burn, check the total supply. We will burn 1 ether of our own. I guess, yeah, this is going to be the same. The balance of ourselves is going to be the total supply minus 1 ether, same as the total supply, minus 1. Okay, 7 test passing. And now I guess what I would like to do is do some real gas optimizations, if they're actually, there are a couple that we could do. So for example, we check here that balance is greater or equal to the amount. So this, I'm guessing, could be unchecked. We don't need safe math for this. Probably the same with this one and with the allowance. But I'm more interested in transfer and transfer from. Let's see, how can we do this? Can we just create a new token? Let's call this token 2. And I know that this is complicated, but let's say this is a second token. And let's add a second set of tests. No, this is, let's see, how can we do this in a way that we can really go over the gas optimizations? Because anything I change here, if I add or remove functions, it's gonna directly impact, you know, the dispatcher. Let's see. Let's do first function test gas transfer from gas usage. No, transfer gas usage. Public. And how was this? Gas left? That's what it is now, right? I want to transfer. Yeah. Okay, let's do this. Let's, on token 2, let's change the way transfer works to be more like what everybody else does, which is, let's do it here on the transfer where we have tests. I've seen a lot of tokens do this. So transfer, they just call, you return transfer from, and the from is the message sender, and then to, and then amount. If we do this, then this one has to be public, right? Because it's gonna say it's not or not yet visible. Let's see. No, right, because it's external. This is exactly what I'm talking about. If I make this public, what happens? Right, that's it. If I make this external, then I probably have to do this, the transfer from, but this is now an external call, which is expensive, so we don't want this. We want that, and we want to make this public. And let's see if our tests, oh, right. This is okay, and we need to fix the allowance. So now we do need to check. Let's see. We say if, who should it be? If from is different than message.sender, then we do this. Let's see. So I call transfer. I'm the message sender. And if it's different, so if somebody else called transfer from, then we do the allowance. Let's see. Okay, so if I'm looking at that correctly, then that should do it. And now we want to check the transfer usage, the gas usage on this way of doing it versus this way of doing it. So we say going to 56, gas equals gas left. We transfer address. We transfer 1 ether. And what we emit log uint. Gas minus gas left. And we want to modify the test to have the highest verbosity and to only match that test. Let's see. Yeah, actually we don't even need all that much. So test transfer gas usage. let's reduce the verbosity to 2. Test transfer gas usage, it used 25,732. And now let's do the same, but with a token 2, which does different kind of balance. So let's create, what did I call token 2? CXX2, easy. So CXX2, I don't like this, but that's fine. CXX2. The setup is all fine. This is gas usage 2, whatever. And can we do this? Named uint. This is CXX. This is going to be CXX2. This is going to be CXX2. So the first one uses 25,700. The second one, 25,600. So that's 111 gas improvement on usage 2, which is this one, right? Because it doesn't do this. I don't know if that, like the call, it's an internal call, so it's cheap. And let's try transfer from as well, because I want to see that. I want to see that too. Let's do, can we copy some of this? Approve. How can I do this as simple as possible? What does the transfer from do? I transfer to a user 1, and then I approve and then do the transfer from. So this does a couple more things, but in the end, they're really the same functions. So that should work for our cases. Let's say test transfer from gas usage, whatever. And let's do the same. Test transfer from, what was it? Gas usage 2. And here we're gonna do, I'm gonna copy this. Before the transfer from, I'm gonna do gas equals gas left. I'm gonna do the transfer from, I'm gonna emit, this is the CXX transfer from. And here I just need to change, these are all CSX2s, right? Yeah. These are all CSX2s. Oh, yeah, that's fine. I'll fix that in a second. This is gas left. We're gonna check this, and this is really when you know, when it's easier to actually inherit, you know, have interfaces, that kind of thing. Can't we have one? Shit. I'm gonna do the easy way. Don't do this, but oh man. Do I dare do this ugly thing? I do, because I don't want to take too much time here. Does this work? No, it's an overload clash, because of course they'll take the same address. Oh my god, I hate this. Yeesh, you're gonna kill me for this, but fine. We're gonna create a user of CSX2. Damn. And even though we have a user2, and this user2 is for the CSX2, just to complicate everybody, I'm gonna create a user3, a user2 called user3, whatever, and user3 is a new user2. Promise I will fix this at some point, but this is just... Oh, and I think I need, because I have user1 and user2. I need to create a user2, user4. God, this is so much fun. And a user4 is a user2. I will fix this. User1. Where is this? User1 is user3. And God, this is so nasty. And user2 is user4. And now, if I did everything correctly, I should be able to check the gas usage of CSX transfer from, CSX2 transfer from, CSX transfer, and CSX2 transfer. Let's see. So what do we have? We ran 4 tests. CXX 25732, 25621, so this is more efficient. This one 27719, gas usage 2, 27689. So yeah, this way it is indeed a tiny bit more efficient. Who would have thought that, you know, having less code, it is more code, right? But you call either this or this. You're not calling this one. That it would take less. So you only need to pay a little bit more when you deploy the token, and that's it. And then it's a tiny bit cheaper every time. So that should do it. Do we need to do anything else? Optimize, non-optimized, test transfer from external public. We did this. We did this. We didn't do this. We did mint, but we didn't really do a good burn. We can do that later. And We have the Enzo Nicolas Perez token. That is perfect. Well, I think that is it for now. Maybe there'll be part 4 where we go over something a little bit more interesting. But for now, this is it. Thank you, everyone.